In this video, we are going to discuss about the Hamming codes. So on the completion of this Hamming codes, the students will be able to understand the concepts of Hamming codes. Hamming codes is nothing but it is an error correction system that can detect and correct the errors when data is stored or transmitted. So it requires additional adding additional parity bits with the data. It is normally used for error correction code. So this linearity property of the code word is that it is the sum of the two code words, so it is called as code word. And the Hamming codes is a type of error correcting codes which can detect 2-bit errors, and also it can correct 1-bit errors without the detection of uncorrected errors also. So when bits are transmitted over the network, they are subject to get corrupted due to the interference and the network problems. So the corrupted bits leads to the suspicious data that can be received from the receiver. So these detecting errors will be finally found out, and this error correcting codes will have the sequence of numbers for detecting and removing the errors in the data that has been transmitted over the noisy channels. While using this Hamming codes, extra parity bits are used for identifying a single bit error. So to perform the one bit pattern to other, few bits are arranged or it can be changed in the data, which we call it as Hamming distance. And Hamming weight, so Hamming weight is the largest number of the ones in the invalid or valid code word. This number is 3 among the 10 code words. That is, the largest weight we are taking is 10 and up to, and the minimum weight we are taking is 3. So if the parity has the distance of 2, 1 bit flip flop can be detected, but it cannot be corrected. Also, any two of the bit flips can be detected. So the main concept of this Hamming distance is it can measure the distance such as lengths, angles and vectors. Also in the binary world, this distances can be measured between the two binary words by something that we call it as Hamming distance. This Hamming distance is nothing but it is a number of disagreements between two binary sequence of the same size. So first what we are doing means to encode the message by Hamming code. First step, we are calculating the number of redundant bits. Next we are positioning the redundant bits. Next we are calculating the values of each redundant bits. So this Hamming distance between one sequence and the other sequence is 1, and the Hamming distance is between the sequence of this 00110001 and 1010100 is 4. So the Hamming distance and weight are more important to find out the concepts of it. And mainly the knowledge of this Hamming distance is used to determine the capability of the code, which is used to detect and correct the errors. If this Hamming weight is chosen as 3, the minimum Hamming distance is 1. So we have to generate in this way the maximum number of error bits, how we are transmitting t equal to d minimum minus 1, where d minimum is the Hamming distance of the code words, and for the code with a d minimum is equal to 3, we can both detect the 1 and 2 bit errors, but we want to code but we have to code the set with a large number of the Hamming distance. It is very possible with directly to detect the errors, and the number of errors that we have corrected is d minus minimum minus 1 divided by 2. And for any positive integer which is m greater than 3 means there exists a linear block code with the following parameters. First one is code length is n is equal to 2m minus 1. Next, the number of message bits k equal to 2m minus m minus 1. And the third one is number of parity check bits is n minus k equal to m. And the fourth one is if the linear block code is having the capability of n is equal to 2m minus 1, then it detects the correct capability t equal to 1, which we called as Hamming code of weight 3. An important property of this Hamming codes is it satisfies the condition when t is equal to 1, and this redundant bits are embedded within the message when it is transmitted from the sender to the receiver. So while transmitting or encoding the message by Hamming code, three steps we have to keep it in mind. First, we have to calculate the number of redundant bits. Second, we have to position the redundant bits. Third, we have to calculate the values of each redundant bits.